So in our example of a graph of a rational function, notice how on the ends, the graph seems like it's starting to flatten out, okay? And it is. It's flattening out along the x-axis. Horizontal asymptotes and slant asymptotes refer to lines that the graph will follow at its ends. So again, here, the graph is going to follow along the x-axis. Most rational functions will have either a horizontal or a slant asymptote, but some will have neither. Unlike vertical asymptotes, which had a strong connection to domain, since horizontal asymptotes and slant asymptotes describe end behavior, the graph can cross a horizontal or slant asymptote in the middle of the graph. Okay, like vertical asymptotes, we often will show horizontal and slant asymptotes on a graph with a dotted line. So here we would have a dotted line going along the x-axis, and the graph would follow along that dotted line on the ends. But again, notice in the middle, a graph can cross a horizontal asymptote, whereas it will never cross a vertical asymptote. How we find horizontal and slant asymptotes can be determined from the function's equation by comparing the degrees of the numerator and denominator. It's a little bit more involved than vertical asymptotes was. So we compare the degrees of the numerator and denominator, and if the degree of the numerator is less than the degree of the denominator, then it will automatically have a horizontal asymptote of y equals 0, or the x-axis, like this example. If it has a horizontal asymptote, that means that there is no slant asymptote. If the degree of the numerator is equal to the degree of the denominator, then you'll have a horizontal asymptote, which is found by dividing the leading coefficients of the numerator and denominator. If the degree of the numerator is exactly one more than the degree of the denominator, the function will have a slant asymptote, which is found from long division. And if the degree of the numerator is 2 or more than the degree of the denominator, the function will not have a horizontal or slant asymptote. So example number 3, find the horizontal asymptote or slant asymptote if they exist. So A, we have f of x equals 4x over 2x cubed plus 1. So we want to start these problems by first either literally making a note or in your head make a note what are the degrees of the numerator and denominator. Numerator just has an x, which means degree 1, and denominator has x cubed, and that's degree 3. So degree 1 and degree 3. We want to match up with our 4 possibilities. And this is number 1. The degree of the numerator is less than the degree of the denominator. So automatically, this function has y equals 0 as a horizontal asymptote. And that would mean that there is no slant asymptote. Part B, f of x equals 4x cubed over 2x squared plus 1. So again, make a note of what the degrees are. Numerator, x cubed, means degree 3. And denominator, x squared, is degree 2. So numerator has a degree 1 more than the denominator. And so this is number 3. We're going to have a slant asymptote, which we will find by doing long division. So specifically, we want to take 4x cubed and divide that by 2x squared plus 1. Okay? And if need be, 0x squared, 0x, and 0. Again, if need be. We might not need those. Okay? So 2x squared compared with 4x cubed, we would need to multiply 2 times 2. And we need to multiply x squared times x. So 2x times 2x squared is 4x cubed, and 2x times 1 is 2x. Okay, subtract. The first two are 0. There's no x squared, so skip. 0x minus 2x is negative 2x. Negative 2x is less than 2x squared, so our division stops. And our slant asymptote is y equals whatever your quotient is up top. You do not need the remainder when you do a slant asymptote problem. Y equals 2x is the slant asymptote. And that would mean that there is no horizontal asymptote. Example 3c, f of x equals 4x squared over 2x squared plus 1. Our degrees, numerator has an x squared, that's degree 2, and denominator x squared, degree 2. So the numerators and denominators have the same degree, and so this is number 2. We'll have a horizontal asymptote that we'll find by dividing the leading coefficients of the numerator and denominator. So y equals 4 divided by 2. Divide or simplify. 4 divided by 2 is 2. So y equals 2 is the horizontal asymptote, and that means that there is no slant asymptote. And example 3d, f of x equals x squared minus 4x minus 5 over x minus 3. Degree of the numerator is 2. Degree of the numerator is 1, or denominator. Okay, so this is number 3, slant asymptote that we will find through long division. Okay, and just as a side note, since we're dividing by x minus 5, you could use synthetic division on this one, but in general, we'll be using long division because you're not guaranteed to have something like x minus 3. Okay, it could be like our other example in part B. Okay, so comparing x with x squared, we need an x up top. X times x is x squared. X times minus 3 is minus 3x. Subtract, minusing a 3x becomes plus. Okay, first two are 0. Negative 4x plus 3x is negative 1x. And then bring down your minus 5. X compared with minus 1x, we need a minus 1. Multiplying negative 1 times x, negative 1 times negative 3 is 3. And then subtract. This will become plus, and this is minus. First two are 0. Negative 5 minus 3 is negative 8. And since there's no x left, our division stops. And our slant asymptote, y equals our quotient, x minus 1. And since we have a slant asymptote, there is no horizontal asymptote.